here my boss came to the University of Florida about 1977. His name is Dr. Canfield, and he was kind of brought in with a group that was designed to treat hydrilla. If anybody's heard of that plant, it's a submerged aquatic plant. Grow about an inch a day vertically and 1% light. It grows horizontally crazy. We spend probably about $27–28 million a year just in state funds on it. That's not federal, that's not communities like you fighting it off, so if you have it in your legs. So we spend a lot of money on it. And so in '77, when he got here, they created a thing called Aquatic Weeds Group, and he was a limnologist, which is a limnologist just means he's a lakes guy, like oceanography that studies oceans. Lakes just studies lakes. That's what he does as a limnologist. That's kind of where I fall into. But he had a couple questions about Florida when he got here, and he knew there was no way that he could get enough data to answer those questions. And so a few people approached him from a local lake just east of Gainesville called the Santa Fe Channel Lakes, or Santa Fe, Little Santa Fe, Melrose Bay, and they wanted to get in the program. They were the first. They wanted to do something on their lake to help. And he says, "Well, I have a lab. I can give you a few little tools, and you can go out and learn how to take these samples." And so they took the samples, and today the same people that were trained in 1986 are the same people sampling today. It's impressive on how long some people do stay with our program, because we were meant to be maybe a couple years of someone staying and rotating out and someone taking over, but these people don't let it go. They've been the same couple that have been doing it. As their kids have grown up and left, they're still doing it. So they take those samples, and then somebody found out that Dr. Canfield, this person told that person told that person, and the next thing you know, he's got 15, 20, 25 lakes bringing samples to him at the university, to his lab, and he's analyzing them for a specific, some data. A couple politicians, one out of Highlands County, one out of Orange County, found out that he was doing this, and he was to the point where he had no extra money. As a professor, mainly what he does in his research world is get money, bring it in, do a project, and he's done. But there's also some residual money. He had some money that was given to him to do special projects that there would be no ties to, that the university just gives him. So he was using that up really quickly by doing these extra samples. And so he's like, I can't go any more than 30. Those politicians says, well, you know what? We have the DNR, which is our DEP today, but back then it was the DNR, for our natural resources. And they said, they can't get enough data. So what if we give you some money? So they started working with him, and in 1991, they said they created the program, and in 1993, they funded it. And so now, money hasn't changed in a long time, but we do have a certain set of monies. The university throws money in to help out, like his salary. Our director, our head chemist is all paid by the university. That's what they throw into it. Then we get our money from the legislative bill, and then we also have counties that help us out, that give us money because of different reasons. Because with our sampling, we can only do so many lakes, and in some counties say we want more lakes with volunteers. We're like, we can't do it. So like Hillsborough County throws $100 grand a year into our program because we can only do about 30 lakes there, but they want 70. So to get that many lakes, that they kind of help out. So the program started growing. So in 1991, when it was first looked at and they approved it, and in '93 when it got its money, and then it grew from there. And so right now we sample about 600 lakes monthly with our volunteers, people like you guys that are coming into this. We have about 100 rivers, and we have about 125 saltwater sites. We're not in the saltwater game. However, about when Jeb Bush was still the governor of the state, he wanted to create a coastal program like Lake Watch for saltwater compared to our freshwater. We had the model. So he sent the money to us and said, create this, you've got it going, and we did. And for 3 years it ran, and then some stuff happened, and since it was only grant money, it wasn't a legislative bill, or wasn't money directed to the university, it got cut by the next group that came in, or whatever happened there. So we kind of lost that program. However, at that time we had about 400 saltwater people sampling for us across the state, and we were like, we don't want to lose them. We've trained them, we've given them our day, we gave them the materials that we'll show you in a few minutes. They have that already. So we told them they could stay in the program until they quit. And so virtually through attrition and stuff and different things going in and out, they've come down to about 100, 125. And so that's kind of where we're at there, even though we have them. And every year they come back to us and say, hey, we want to get that coast thing going again, because we get a lot of freshwater lake people calling us and coming to our website and wanting to get into the program. but the coastal side is crazy. You know, it doesn't take very much to get people that want to sample the coast, because that's where a lot of people get moved. You know, they move to the coast, it's Florida, and so it's easy, but they don't want to give the money yet. So they come and say, hey, can you start this and redo it? But they haven't come up with the funds yet to be able to do it. So right now, that's kind of where our program is. We are set up for trend analysis. Our job at the university is purely research. We come, train you, you get to take the samples for us, you get it back to us, and we look through time. We want to see wet periods, dry periods, hurricanes. We want to know what's happened through time. Changes in population, changes in the dynamics of forestry to agricultural to development. That's what we're kind of charged with looking at. We're not in the business of regulating. We're not in the business of that. Our job is just to collect the data and get it out to the managers and the regulators that are out there. We also don't hold this data. This data is on, it goes to there's a USF runs a thing called the Water Atlas. It was done by a man named Jim Griffin. Our data, every quarter when we download, they get it. So his Water Atlas program gets our data. He wants it to be a clearinghouse. It's a place where the district sends their data, the FWC, the Florida Fish and Wildlife Conservation, sends their data, the DEP, which is the Department of Environmental Protection. All this, he wants all this data, so somebody like you, if you want to know about your lake, can go there and look it up and get whoever's done anything on it. It's not working as well as he thought, but it is working pretty good. But he gets our data quarterly that we adds up to it. There's FWC offices, there's district offices, water management districts. There's 5 of them in the state of Florida. They get our data. The DEP gets our data. Everyone that is out there doing something, we do not hold this data. We don't put it in a filing cabinet and shut it down. It goes out there to be used. Yes, sir.
When we send in our samples, what do you test for?
Okay, well, what we're looking for is we do phosphorus, total phosphorus. We don't break it to components like orthophosphate stuff or like nitrogen, ammonia, nitrate. We look at the totals because everything that you're going to do is freezing, and there's a low degradation on totals. To start looking at components, you may have to have fresh samples, and it's almost impossible for us to do this many lakes and get all those samples back to us in a short period of time. We do total phosphorus, we do total nitrogen, so that's your building blocks, that's your nutrients. Just like out on your lawn, if you put phosphorus and nitrogen on it, it turns green. Same thing in a lake. You have more nitrogen and phosphorus, you grow algae. We do algae also. We look at the chlorophyll component of it, we look at the biomass. I don't look at speciesization, that takes a lot of microscope work and different things. We look at the biomass. So with the algae, which is your microscopic plant, and the nitrogen and phosphorus, which are your nutrients, that's your building block. Everything in the lake functions from there. You have more nitrogen and phosphorus. In theory, you grow more algae. In theory, if you grow more algae, you increase your food web. The invertebrates increase, your minnows, your small fish increase, your big fish increase, and that brings your birds, your gators, your turtles. And if you look at the cascade effect on almost any different studies out there that look at that type of stuff, it's an increased nitrogen and phosphorus, increased chlorophyll, unless you're in a colored lake where they're tannic stained, they get a lot of brown water into them. That color comes from the humic material, and so as it rains, it hits the land, that water flows in, it gets all those acids and stuff off of those rotting leaves. That flows into the lake, makes it reddish, makes it brown. Almost every county you go to, you have swampy areas, and that's where you'll see this. You'll have Red Beach Lake, you'll have Red Water Lake, and they look really tea-stained. The Okefenokee Swamp is a good example. It's almost black, but it's the same thing. It's that same material. It's just on that other side. Color lakes can have a lot of nitrogen phosphorus, but they can't grow chlorophyll. They can't grow a lot of algae like our normal lakes because light. Light can't penetrate that stained water, and so if it can't get down there to the algae, they don't grow. Even though there's enough nutrients for them, there's not enough light. So those lakes are separated kind of different to your normal clear water, hard water lakes, or your clear saltwater lakes. So we do the nitrogen, the phosphorus, the chlorophyll, and we also do water clarity with this disc that we'll show in a little bit. And that we use because it's the data comes to me. I have 5 months to get it through for the DEP to be able to use it. We can hold it in Lake Watch for a year. We've run numbers, and degradation is very, very small, so we can hold it for a year for the things that we do. But for DEP to use it, and this is where our lab tries to get to, is 5 months. So like you guys take your samples, I come down every 3 months, I get them, and that still gives me 2 months to get them back and get them analyzed through my lab for those things. We also do color and conductivity. We do that because that's where the lakes get separated. DEP, to look at impairment, they have to have color, and they want alkalinity, but conductivity they'll also use that. We can't do alkalinity on your frozen samples, but we can do conductivity. So we look at that. And so by getting those 2 extra ones, we don't do it every month. Like if you go out monthly and sample, we always do phosphorus, we always do nitrogen, we always have our algae content, and we have a water clarity that you do and write down. We'll show you in a second. Those 4 parameters, always. Every other sample, we do color and conductivity, because it's not part of our legislative bill, but we need it because it's good data, and it helps us distinguish what type of lake you have for DEP's impairment rules. It lets us know if you have a color lake, you have a clear saltwater lake, or you have a hardwater lake. And so we do those also, but that's something that you won't do. It's just in your sample. You just collect it, turn it in, and their lab has to pull from that and do that. So that's our parameters, and so that gets us kind of through what we do, kind of who we are with the program, and then. But I also will say that, and then yearly, we send you a report, and the report is based on how DEP would use your lakes for impairment rules. It gives you your data, but then it talks about how you can see if your lake, even though they probably started out as stormwater ponds, as time goes by, like if you go into Miami-Dade or you go into the Broward County area, and when the turnpike was built and 995 through that area was built, a lot of those lakes in the 40s and 50s and 60s, they're now people's lakes. They might have started out as stormwater ponds, but they have fish in them, they have plants in them, and people are managing them. So that's why we let them in our program, because most of our lakes in the program are in Lake County, Orange County, Seminole County, Tampa, the Hillsborough County area, and those are all more of a natural lake system. You move down into the East Coast, or even here with you guys in the West Coast, you're building lakes every day because of the growth. And the first year, second year, third year, they are stormwater ponds, but as people move on them, activity starts around them, they start growing fish, they start growing plants, and then things get turned over to you guys, they become lakes. And so down here, this is really our only choice. If we want water data, and it's water data, we need to know what's going on, then we allow these lakes to be, these type of lakes in our program.
Do you have a timeline on that? Like, if you don't sample stormwater ponds until after 10 years? Or
No, we would just start doing it, just to start building the database, especially here. If somebody in Orange County called me and said, we want to add a stormwater pond, I probably wouldn't let them, because Orange County has 400 lakes or whatever it is. It's a huge number, and they have a lot of natural lakes. Probably someone from the Lake County called and said we wouldn't do it because we have 70 natural lakes sampling in that county. But in Broward or over here in Fort Myers, Collier, Lee, we're going to try to help out.
If it's
Yeah.
a brand new lake.
Right. If you want to, if it's, I'll rephrase that. If it's going to have water in it year round.
Right.
If they drain it and it dries up periodically because it's a very shallow one, then we won't long term. We don't need something that's going to dry up and be gone for 4 years. Now during wet period and dry periods, some of our regular lakes dry up, but that's a normal thing that happens with them because of their hydrology. Yeah.
So we would expect to get feedback from this once a year?
Yeah, but on the side of that, that's through the DEP report. That's once a year, we'll send that out. I send stuff to Jim, and he sometimes posts it and does things with it. He's starting a great website that you guys can access. But I have another report that I can print for you that I can do anytime. Every time I get a data download, so every 3 months when the lab sends me the data, I can print that report. It's a little different, and I can still tell you how that data fits that other report, but the other report is so complex, and it's an 8-page report, and virtually what we do is in October, early November, we take our database, we shut everything down, and then we start managing it or manipulating it, I should say, to get it into the spreadsheet form that will merge into the report, and that firstly takes about a month to get all that done. So by January the next year, we have, so let's say this is 2018, so I'll have all the 2018 reports ready January 2019 to start handing out to people throughout the year. And what we do is, you guys have not had one of these yet, and maybe we can try that maybe this year. We'll talk about that for Lee County. Maybe we'll invite Collier and Lee County to that. Is we have meetings in every county every year for our volunteers. So like in Lake County, once a year, it's usually April or March there. We invite all the volunteers in that county. They come to the meeting. We serve lunch, we give them their data packets back, and we talk about lake management for 2 hours. And then if they can't come, we mail it to you. It's not been done in these counties because we just haven't had a lot of water bodies yet. And if you look at, even though we're 30 years old, we started in Gainesville, and where do most things start from? They start from where they're center out and they move out. So virtually the Panhandle, these South Florida areas were slowly, getting into these areas, and they didn't have as many resources as some of the other counties did. Seminole County has their own. EPD, Orange County, some of these other counties are coming into the game later, and they're starting to do these type of things.
Let's assume that the sample shows highly elevated levels of phosphorus in a particular lake all of a sudden. How does Jim find out about that?
Well, he'll get the data, he'll get the reports, you'll get the reports, you know, if you can, you can see them, you can go on our website, and they're just available to anybody. But what I send you, let's say you sampled Sandoval Lake 1, even though I give Jim the data for all the water bodies every year, if you were the volunteer connected to that water body, you would get that report. If you wanted any of the other ones, you could go on our website, or you could get it through Jim or myself for any of them. If it says it's elevated, again, I am research only. So that's negative. But I can give you my opinion. I can give you, our data does lead to management. All of our research side of us leads to management. The other side of my job is just not training you guys, getting the water sample through the freezer and getting it back to the lab. The other side of that, my job is running the research projects in my area that come up through time through my boss. Like we just finished up bacteria for that Santa Fe Channel Lakes. We did a year's bacteria work on that. So that was my job to get that sample and get it back in. That leads to the management side of stuff. What we would tell you is you'd have the report, it showed elevated stuff. That would be up to you as a community to look at it, and then you could say, hey, what if we want to do this? Or we hired a consulting firm and they say they want to do this, what's your opinion? Then I can tell you what I know of and what the data suggests, or what's out there. Like for example, a lot of people want to move to, years ago they were moving to fountains. They wanted to put fountains in. These fountains pull water up, they look pretty, but as time has gone on and the research has shown, they don't really do as much. Most people are moving more to bubbler systems now, and the research has pushed us to that, because now we would say, if you want it there for visual, will it move a little bit of water? Will it oxygenate a very small area around the fountain? Probably so. If it's a small lake, good enough. But if you have a 5 or 10 acre lake or something, and you have some holes in it that are anaerobic, or you just want areas, you just want to move the water from the bottom to the top and have a better circulation, then we would move you to the bubble systems, because the other ones are very expensive to run. Most of them are 220. You want to run them. They're expensive. The other ones, they're working them out now, and so they're very cheap to run. They're expensive to put in, but anything in the beginning, but they're easy to maintain and they're easy to run, and they move water. You put them in a grid system and things change. So that's the stuff that we offer, is the ability to give you our opinion on different things. But we won't come do any of the management. We're not into regulation. So if you do something as bad and I see it, I'm not turning anybody in on anything. My job is to create a database. And that's what keeps us in a non-biased group, and that's why we're at the University of Florida. We're there to create a research database with you guys. Economically, it's cheap. For me to go out, it's very expensive to hook a boat up, hook a truck up, take a technician, because I can't go by myself. Go out, take those samples, get them back. If it's you, your time, your boat, and all I'm doing is spending this afternoon with you, training you, and then coming and get the samples every so often, or once a year having a meeting or sending you a data pack, every month you guys sample, the cheaper and cheaper it gets to collect these samples. I don't know, 10 years ago, the amount of samples collected in Orange County, somebody did a small analysis on that. I think we were saving Orange County $500,000 a year or something like that, just with volunteers in that one county, just through the program. And that's our whole budget. Our whole budget is only $500,000. That's all we get through the state legislature. So we've saved some of the counties quite a bit. And that's why some of the counties kick in money to help out if they want to add lakes, because they see that they can get this information back to them. Because with this nutrient stuff we talked about, we'll talk about that as we go on through the thing, but there are specific impairment rules that DEP has, and a lot of your counties have to have water data to turn in for that. Some of those stormwater ponds fall outside of that, but in our natural lake system, you have to have that data. So like Seminole County, they really go out every quarter and sample. Then our volunteers in those lakes sample monthly, and that fills the gaps for them. And because they have to turn in data to show that their lakes are doing well on the natural side. What's that?
What happens if they aren't?
Well, then that's going to be an interesting thing, because we really don't know yet. Some cases they might make the county do the work, or they may make the city that the lake is involved do the work. Some areas they may do the state maybe do the work, or that the state may say, we'll give you funds, but you've got to give the personnel. I don't know what's going to happen. This started out about 10 years ago when the federal government pushed a one-number system on the state of Florida and other states, where they said you're going to have one nitrogen, one phosphorus, one chlorophyll, one water clarity number. And those values, if you go above them, you're going to be impaired. Well, it made Florida, a lot of our lakes are going to be impaired. I want to look at 60, 70% just in our database showed that. But what the EPA wasn't thinking about was we're an uplift. We're a long state, and our geology is different. You can start in the Panhandle, there are very different water bodies there, and as you go down the state, it changes. Our geology, in Polk County, we mine phosphorus. It's sent around the world. It's one of the, more phosphorus comes out of that county than anywhere else in the United States. Every lake in that county is sitting in a phosphorus phosphorus bed. And so those lakes have a lot of algae growth. Every one of them would be impaired based on that rule. So DEP started working with it. Luckily, we had this database. This is a huge database, and it allows modeling and different things to occur. And they were able to come up with that impairment table that you would see now in those reports. And now we have it so that we have 3 types of lakes with 2 different sets of nitrogen and phosphorus, if you, depending on your chlorophyll to look at. And then we have a secondary thing that we built based on geology. So it's a step process now. And so it's just not one number. That was how it was come about. We don't even, I'm not even sure, you know. But with this database, that has changed how that is looked at. Now, they were sued. This table got in. It passed everything. All the judgments got out. So now this is in law. This is the word. They started probably 2 or 3 years ago, technically going through looking at lakes and doing these impairment things. Some of the public water bodies immediately that are impaired, that are probably the larger ones, they started working on doing different types of management plans to bring them out of that impairment values. Smaller lakes, we have 7,200 lakes in the state of Florida above 10 acres. We have 100,000 water bodies of any size. Where do we go from there? I'm not sure. You know, because if somebody calls up and they're on their lake in Volusia County and it's a 50-acre lake and it doesn't have public access, but it is impaired, how do they work on that? I don't know yet, because in many cases the state owns all the water, but if they don't have access to it, it's not considered public. So if it has a boat ramp on it, or has a park on it, or has county or city has access, then that opens it up to actually getting state or federal help, depending on what they can do with it. Water bodies that everybody owns around it are considered private, even though someone can land a helicopter in that and take samples. You know, you can't stop them if they're state or, you know, a federal agency, because it is state waters. But if they can't get access to it, a lot of times the money doesn't come to that, and that becomes part of your world to fix. I can give you an example. Lake Holden in Orange County. They've been a very green lake since the 80s. A lot of phosphorus and nitrogen. You can stick your hand in the water, not 12 inches down, can't see your fingernails. Very green. Produces a lot of fish, though, because there's a lot of food there. They wanted to clear it up. So they made themselves a taxing district. So every house around that lake put money into an account. That money went into account at the city of Orlando managed, but the city couldn't touch it. In law, it was only for Lake Holding, and they made their own taxing district. They put that money into it, and they created an alum plant. Alum is an aluminum oxide. It's used to bond phosphorus, settle it to the bottom, pulls it out. So no nitrogen and phosphorus. Algae doesn't have any food to grow. They fall out of the system. But that's sometimes a temporary fix. You got to do some other things to do it. So what they did is, by doing that, they put the alum in the lake. It settled the phosphorus out. They found all the entrance points. Every time it rained, they injected alum into those entrance points. So anything coming in bound up also. So nothing was getting into it. Then they went to all the sites around, found out where the stuff was coming from, bought land, made retention ponds, and pushed that water into those retention ponds to stop it before it got to the natural lake. So then the lake started clearing up. That started allowing a plant called eelgrass, Valsina americana, to grow. That plant took over about 40 to 50% of the bottom of that lake within 3 or 4 years. The lake now is very clear. They just managed the plants, and no more alum is going in it. So that's what they did as a group on what's considered a private water body. Even though it's a couple hundred acres, it's a bigger water body than what you guys have. They ski on it, they boat on it, different things, and fish. But they had to do it because there was no public access. Now you move to the bigger lakes, Lake Apopka, Lake Jessup, Lake Kissimmee, Okeechobee, all of these lakes that have boat ramps and stuff, they're being, managed by the state or a federal entity, depending on who it is, or the city or the county. That's on them. Some cities and counties manage the lakes if they have access on them. Yes, sir.
Does lake bank erosion tend to have any impact on water quality?
It can, yeah, for sure. But in smaller water bodies to an extent, and a lot of people will plant like emergent grasses. The grasses and the pickleweeds, and these are emergent plants, or ones that they have a hard stem and their leaves are out of it. They get all their from the sunlight. Submerged plants are the ones that grow on the bottom, and their leaves don't come above the water. But these emergent plants are around, and so if you have wave action, it dissipates it, and keeps that from happening. Some places where I was at, Lake South in Hillsborough County, I trained them last week, and they have a large water body there, and theirs are all bulkheads. They've done that for erosion control. However, today's research is kind of showing that we don't need those vertical stone bulkheads. We're trying to get people to move more to a rocky substrates and make it come down at a slope, because the flat ones don't hold a lot of epiphytic algae for stuff to grow on. So when you start looking at your studies, if you go there and sample a meter square of that wall that's in the water, there's a certain number of algae growing there, a certain number of invertebrates eating it. But if you move to rocky things where you have all these crevices and stuff, we find gobs more in that meter square of information. So a lot of the data is pushing people to get away from those if they're looking for erosion issues and they want to have that type of a structure. But most people just plant vegetation. You know, you started out, there are specific ones you plant here that'll grow higher, and you need a succession of them all down right to the edge of the water. And as it was, you know, and so especially places like boat activity, Lake Ivanhoe in Orange County was a good one. It's a big ski lake right there in the center of town. For years, it had no plants in it. Now, Kevin McCain was a gentleman that headed the city there. He worked on getting all that set up with the FWC, and now that lake has about 40% of the bottom of the lake covered in vegetation, has emergent grasses all the way around it. So those ski things, they don't have to bring dirt in anymore or anything, because the erosion now has almost been eliminated.
So, given the beneficial benefits of littorals, can we look to Lake Watch as a resource for helping us
For
find-
education, yes, for letting you know that I have pamphlets on like types of plants that you could put there, depths that they can be planted. I can't tell you places to go get them, you know, but I have information on like a little spreadsheet that Dr. Lang put together years ago. That's a bunch of contractors where you can go call around, look around, and see who you want to use, that type of stuff. That's what we're here to help you do. And if, like he uses the term littoral, just to let you guys kind of know, that's that area of vegetation from the shoreline out into the water. So like your areas, that littoral zone can be 4 foot, it can be 0 if there's nothing there, or it can be, as you can go to Lake Poinsett in Brevard County, it could be a mile wide. You could go to Lake Okeechobee, some of the littoral areas, those shallow areas that have vegetation growing through them, can be 2.7 miles or 7 miles wide. They're huge areas, and that's areas where juvenile fish can come in. They can move through those plants and hide. Invertebrates feed on them, the algae that grows on them, and they feed on them. So some of those little areas, littoral areas, become like estuaries for the small fish. But they also become hunting zones for the bigger fish, because they'll float around the edges of them, and those little fish peek out. That's how they feed on them. They become.
You had mentioned the analysis that you're doing, and also the benefit of bubblers as opposed to fountains. Do you, I don't recall if you said, do you measure the oxygen?
We do not. There's only, we had to have a very specific set of stuff, and oxygen changes dramatically throughout the day. Most people, the best part of oxygen, if you want really good data, is right at daybreak. It's hard to get a volunteer group to get out every morning right when the sun starts to come up at 6:35, and go take that sample. The other problem is we would want you to do it with a meter, because that's where we're going to, and then they be calibrated. They're expensive. You know, a good one's going to cost you $1,000. And for us to have oxygen in our program, that would be, if we had 600 lakes doing it, $1,000 a piece. This here already cost me $400 to $500. And again, so we had to have a very specific plan, and we needed the best bang for the buck. And the nutrients, the chlorophyll, and the water clarity became that. Oxygen is not I mean, it's a good thing to know, but early morning is its lowest point, and that's the best time to know. Then it starts coming up during the day, and by 1, 2 o'clock, it could be at supersaturation. It's kind of a bell curve. And then as your algae and your plants are making it during the day, then it hits the nighttime. Everything that needs oxygen has to have that reserve there and use it. So that early morning hours, when it's almost used up before the sunlight comes up, that's that crucial time. Most natural lakes, like I say, they have a very specific amount of plants in them. They have a very specific ecosystem, and they're moving through time. If you start seeing fish kills, that might be an issue for you to then think about O2 as being an issue. If you're not seeing them, it's no problem. But in the state of Florida, there's going to be some no matter what. We have a fish kill pamphlet that we took a bunch of data from the FWC and the water management districts, and we wrote a pamphlet that's on our website that you can go get. Most of them are natural. But what happens is we get, in Florida it rains a lot. And what you do is, if you can't make enough oxygen to get through those nights, they'll crash. And what happens if you get 3 or 4 days of cloudy weather, and our algae and our plants in those lakes can't make enough oxygen to keep up, on that 3rd, 4th, or 5th day, it starts to struggle. And then if the fish can't get away and go someplace where there is oxygen, then they start to die. However, in most cases, the rebound, unless it happens a lot, is pretty quick. A largemouth bass at 12 inches is about a year old, and after about 13 inches, just 12, 13 months, can start laying eggs. And so and they lay a lot of eggs. The problem is most of those don't get into the system. So if the habitat has everything it needs, those fish can't move in. They're just food. If you had a fish kill and you lose a bunch, that habitat opens up and those fish move into that system very, very, very quickly.
Other than correctly measuring the oxygen level, what's a good indicator that you need some sort of aeration in the lake?
That's kind of it, for the most part.
Fish kills.
Unless, some people will go out like, Bear Lake in Seminole County. They actually they spent they're another taxing group that built their own money to do stuff, so they had projects done, and they had some holes that they thought were anaerobic. So even though the lake may be 7, 9, 10 foot out in the areas, they had some 17, 20 foot holes, and they wanted to do something, so they paid a consulting firm, came in, ran a grid across it, did a bunch of O2 profiles, found that had a couple holes that in most cases were anaerobic. They weren't getting what they needed there for oxygen, and that's where they put a bubbler system. But they paid somebody to come in and look at that, and that was more done on depth. They found the depth, then they went and looked at the oxygen type stuff. So they added another component to it to find out where to go, where to look. But in most cases, most water bodies, they go through time and they're doing what they need to do.
Some of these lakes are up to 13 feet deep, but at about 6, 7 feet, the oxygen just went to zero. So it shows there's a dead zone down at the bottom. So the only way to recover that is to get dissolved oxygen down there through the bubblers systems. So
How far down do you typically expect oxygen to be available?
it depends on the lake, its
Yeah,
depth,
every lake is
the amount of plant life that's in it. I mean, those are all things they also looked at. They ran scans and they really produced some very detailed information. A lot of this stuff, including the Lake Watch results, are available through the Lakes and Ponds webpage. Everything was put online for that purpose, to make it very transparent to the group. The Lake Watch alone, we start with the library, of course, because if you're going to get into these results, definitely there's some great beginner guides to water management, and certainly there's a way in to those results, because they can get very deep very quick. But anything that we're getting that we think is worthwhile, we're putting online. We're making that a community resource.
And that's a good thing. You guys have a community, you have a group, and starting a website like that is a good thing. Most of our lakes, even our larger, natural water bodies, we talk to people. If they have an association, we suggest that they create a lakes committee, or they create an association so they have a lakes committee, so that different types of things like that can be done, where you can have the educational side of it. You can put a website up, or someone will take our reports and then at their local yearly meetings, give them out to people and discuss what they discuss with us, so more people understand what's going on their water body. But that resource is great. I've looked at it a little bit, and so it's a nice way for you guys as a group just to go kind of see everything that's already been done or is being done now. But what we'll do now is we'll just start going through a little bit about the what you have to sample and how you do it, and then from that you can continue to ask questions as we go. Your little guys are a little different. For one thing, most of our lakes, I go and it's 1 or 2 people. I get to the lake, they have their boat ready, we get in the boat, we go out, we take the samples. When we get larger groups like this, most of their trainings are inside and they're just hands-on doing, because you have the smaller kayaks and stuff, they're harder to get out in and stuff, so we train you this way. But you're going to get the same information. We give you a set of materials here that you're going to use a sample. You guys have some already, and Jim brought those in so you can see them, but I had a spare set with me to see with you guys. Every one of our kits you can get this online also to our website, but we're going to talk about today how to sample, how to process. It's a little screen printed card that it floats. You can take it out with you. The booklet, don't take it out if it gets wet. It'll mess up. But it has pictures in it and reasons why. And it's a little more in depth than the card, but that's there. But Jim probably has some of those in the kits. If you don't, you can get these off our website. You can download them. They're right there. But that's in there. So even though we go through this and it's only an hour or so of us talking about it, there is aids that we give you that will help you guys work through it. And then Jim's been doing it for a long time. So for you guys, that's a helpful thing. You're just not being thrown into something. You already have people here that have been doing it. You're now coming in and helping them. So you have people that already have been out going and doing this stuff. So the first thing we have to do is, in our sample, we have to pick station locations. Normally, we go north, south, east, or west, depending on the long length of the water body, and we put 3 sites. If the lake is small, we'll go down to 2. But for the most part, every one of our water bodies have 3 sites, and we do that because of our statistics, and it also and we do it open water. So almost all of our volunteers have to have boats, a kayak, a canoe, somebody to get out on it, because we don't want you taking samples in that littoral zone, because there's bacteria and stuff in there that can influence the water, and we want the lake to mix. So we do open water samples only outside of that littoral area, and I brought a couple here that you guys can pass around. And some of our lakes have more, but probably 90% have 3, about 5% have 2, and about 5% have more, because like Lake Kissimmee is 11 miles long. You know, we need more sites. At Lake Tahoe, it has 3 distinct basins, and so we have 3 sites in the north side of Tahoe. So we call it North Tahoe, Middle Tahoe, and South Tahoe, because in the north side of Lake Tahoe, it's very green, a lot of algae coming in from they're closer to the city, the town of Kissimmee. In the middle, a bunch of creeks come in, and it gets that stained water we were talking about, so it's very colored. The southern basin has hydrilla in it, so it's very clear, and it's aquatic plant dominated. So those 3 basins, even though it's one lake, they all function very differently, so we have volunteers sampling each one. Lakes like yours, when they're very small, we only have 3. Most of our lakes are that way. Most of our lakes just have like a 3 sites. And again, we do north, south, east, west. We usually try to find the longest link, and we go that way for you to set those up. So you can see that. We try to get GPS coordinates on all of them. That way we have that there. But general locations, what you need to be more aware of. You need to make sure your 1 and your 3 stay on those sides and 2 stays in that middle. We don't want to flip those. You make that mistake. A lot of our volunteers, if they don't have a GPS to use those coordinates when we first set them, they'll use like a points. They'll use a north and south point to stay in a straight line, and then they'll just use something on the shoreline like the edge of a house or something that when it comes in a straight line, it gets perpendicular, that gets you back to that general location. Some areas put floats out, but some people don't like the floats because they don't like to look at them, and we can't put floats on public water bodies because people steal them. They just do. But you find your sites, so you get your 3 sites or your 2, you set those up, and then you get ready to go out and sample. This is the materials that we give you to go sample with. These bottles, you see everything comes in packs of 3, because almost all of our lakes have 3 sites on them. This is for that nitrogen, phosphorus, and that color and conductivity. There's a data sheet in every one of our packets. We give you 3 jugs. These jugs here you use over and over again. This is going to be for your algae sample. This is your water clarity device. It's called a Secchi or Secchi disc. Some of you guys may have seen them before. Some may have taken classes before. May have seen them black and white. We do white because it's cheaper. And we've done a bunch of work with different universities, and we've had a couple of students do some studies with them. We find very little difference in black and white, so instead of painting the wedges on them, we just leave them white. Biggest issue with this is your eyes, and we'll talk about that when we do it, but whoever does this on that lake for that site, 1, does it for site 2 and does it for site 3. If you're with a partner and you're out sampling together, don't change up with this, because that's the biggest issue is for that month, that sampling day, whoever does this does it all 3 times because everybody's eyes are different. So that's why that's the biggest issue other than the black and white. And a little information about it, it was actually a disc that was designed by, the Pope had a Navy, 1500s, and he wanted to see where disappearance was. So he talked to one of his admirals, and they talked to another guy, Secchi. He went into a galley, got a pipe plate, tied a rope to it, and where it disappeared became that thing, and his name got connected to it. So it's kind of an interesting little story on how, and it's been there forever. We do these vertically. If you guys do any kind of diving or snorkeling, and you go to the Bahamas or you go to the Cayman Islands or the Keys, and they talk about visibility out there, some of those are done horizontal. They'll sink down, swim out with the same disc. It's bigger, but they do the same thing. But it's a little harder, even though there's sharks in the ocean, it's a little harder in our lakes to say, hey, how about you take 2 people, you jump in a lake, and you swim away with it. So we had to come up with something different. So in the limnology side, it's done vertically. But that's your disc. But these are your items. So what you want to do is, first thing you do is you get ready to go out. You guys have a group, so you're going to be able to do things in stages. But most of our volunteers, they have to do everything themselves. But like you guys, you could have a set filtering, a set going out, taking the samples. However you guys do it is completely up to you. But most of our volunteers, they just get ready to do their thing. And so sampling, first thing is labeling. We have to know where everything is at. We'll let you pass a couple of these around so you can see the bottles. But every county has a clear lake, a blue lake, a spring lake, a silver lake, and so we have to know where they are, because when they come to our walk-in freezers, These samples just get stacked in there. A technician comes in and gets the stuff out, separates it, and knowing where everything comes from is very important to us. So if you look at the bottle, there's a spot for water body name. There's a date there for county, date, and station. 3 stations or 2 stations, whatever you do. So you put the lake name. I think you guys are running like Sandoval 1 or Sandoval 20. You have a deal like that with your stuff, and I think you also have another code system. I think Former, is that? Yeah. So whatever name you're using, or Jim talked to you guys about, that's the name you want to use because that's what we have in our database already. So you put your name, you put the county, and the date. We want monthly sampling. You're volunteers. If you give us 6 months, that's better than nothing. Nobody else is doing it and collecting the data right here. If you give us 12 months, perfect. That's what we'll take. Give us 3 months. We're going to take that. The more you give us, the better. But we want 1 a month. But we want you to keep 25 to 30 days between them. We don't want you to go out on June the 30th and July the 1st. We need to have 25 to 30 days between, so it's a monthly sample. If we get something like that, even though it's technically 2 different months, for us to use in our database, we'll have to average them all or just throw one set away. We need them on a monthly basis. So labeling, we like them to use the Sharpies. That's the best thing to do it with. We used to, not really an issue now, but when I first started this stuff in the early 80s, some of our pencils were still graphite, and if you would use a pencil on these and put it in the freezer, sometimes the graphite would just slide off. But most of our pencils aren't that way anymore. So we started using the markers because they won't. If you do these ahead of time before you get them wet, they'll stick really good and they won't wipe off. So this is the best thing. So we ask you to use this. We don't care what color. The black ones is what we give out when we first train you guys. So we have you label them, and I suggest labeling them before you go out. Get everything ready, label it all together, and get it set. We'll pass the data sheet around. The data sheet is the same way. Could just pass it down. It has lake name, has county, and you want to label that also.
We got that on.
Oh, you got one on there? Okay. Pass one down. You can see that top part has that same information. You want to put down lake name, you want to put down county, the date, your name, and you want to put down your phone number, because what may happen is we'll get something in and the lab have to call you and say, hey you guys, Jim, you made a mistake over here. What was your SECI? I couldn't read it. And if you can remember, they'll get that. That helps us fix it really quick. I'll have your information, but then the lab has to call me and I have to go do it. So if you have it on your data sheet, that's why it's on that one little spot there for you. So I suggest fill your data sheet out, fill your bottles out, and then you're ready to go. You have that. You have your 3 jugs, and you have your SECI. This is all you have to take out with you. So depending on your canoe, your kayak, whatever you're using, this is the items that you have to fit in it to go out with you. So when you get ready, you're using kayaks and canoes. Most of our bigger boats, we ask them to anchor. You guys are going to be able to control your stuff a little better. If you want to anchor, sure. But if there's 2 of you in it, or if it's a kayak, you can keep yourself in that one little direction, because what we don't want you to do is take your sample at your spot and then float to shore and take the rest of it over here. You need to stay in that general spot. So if you need to anchor, please do. However, if you control the boat very well, then you can sit there.
We go out on very windy days, so the anchor is helpful to have.
Okay.
So that as far as
Yep, that's the same one I have in my kayak. Yeah, so having those will help you stay in the spot, because you're going to be there a few minutes taking this sample and getting ready. And like I said, they have it. So the first thing you want to do is you get to your spot in your kayak or your canoe, and you get ready to take your sample. You take your number 1 bottle. This is sterile. You do have nitrogen and phosphorus on your hands. You do not want to get it in this bottle. So what you do is you do a double rinse. You get this bottle ready, because what will happen is I'll acid rinse these. I'll use a deionized water to clean them, and then I put them in dryer ovens. But with 600 lakes, that's 3 samples on average per lake. That's 1,800 samples just for nitrogen, just for phosphorus, and just for chlorophyll that's got to come in and be used. If they don't get dry in time and we have to pack them up and get them out to the volunteers, they may have some droplets in them, but that's that deionized water, so there's nothing in it. So you're rinsing this bottle twice, so any water droplets are your lake water. So you just put a little bit of water in it, you cap it, fill it about a quarter, shake it, dump it. Do that twice, keeping your fingers out. This is a double rinse. You've rinsed it twice, ready to go. I suggest holding onto this tight or setting it to the side, so you don't stick your fingers in it. I like to set them down on the edge. This is called the spider grip. You grab the bottle and you invert it right into the water. The reason you do this is there's pollen that floats on the water. You'll create an airspace by sticking it straight down. Nothing can get in the bottom until you get down to it, and then you turn it horizontal and you push it. By pushing it, you create a current behind your hand. And so by pushing it, that current pushes any nitrogen or phosphorus to the back of the bottle, and then you fill it up. You can also spider grip, elbow depth, and turn to whichever way the wind is blowing. If the wind's blowing to you, turn it into that wind so everything stays blowing behind you and let it fill up. You can do either one. I like to just elbow depth, spider grip, turn it horizontal, push it, bring it right up. It'll be completely full. Dump it about 1 inch out because you're going to freeze this, and this is expansion. And the bottles are pretty tough, but since we do use acids, they slowly deteriorate them. So if we overexpand them a lot, they'll start to crack faster than they should. So about 1 inch, just dump it about 1 inch out. Take your lid and cap it as tight as you can. They're guaranteed not to over tighten. Tight as you can, and that's your nitrogen and phosphorus. And every other month, that's our color and conductivity also. So we'll get everything out of that. Again, and it's a subsurface sample, and the reason we do that is there's all kinds of other ways to sample. There's column sampler where you stick a column in the water to the bottom like a straw, bring it up, put it in a bucket, mix it, take it. There's things called Van Dorns that'll do horizontal. There's Kimmers that'll do vertical, and you put them down at certain depths. But we needed to find a way to do everything universal and keep it so that everybody doing the same thing, and we can compare our data. Also, your FWC, your Fish and Wildlife Conservation Commission, your DEP, a lot of their surveys are subsurface. So that allows us to compare our data with everybody else. And I'm sure the city and the counties do the same thing. It's because the Van Dorn costs $500. And if you wanted to use it. Yeah. So you start buying all this equipment, and we couldn't buy that for you guys and keep us cheap. So we had to come up with a way. And so by doing an elbow depth, that's about 1/2 meter. So it's considered it's called a subsurface sample. So again, uncap it. Rinse it twice, double rinse, elbow depth, horizontal, give it a push, fill it up, dump 1 inch out, cap it as tight as you can. You're completely done with that. Set it to the side. You're still at station 1. You grab your #1 jug. You're going to use these over and over again. You do not have chlorophyll on your hands or your fingers, so you really can't contaminate this one, but we follow that same double rinse method. Put a little bit of water in it, cap it, shake it, dump it. 2 times, cap it, shake it, dump it, elbow depth. Don't have to push this one. You can't contaminate it. Fill it completely full. Bring it up and cap it. Now,
When you're doing the rinse, how deep are you?
about that much. Oh, just same thing. Just about elbow. Just kind of stick it under the water, about elbow depth. Just put a little bit in it. Cap it, shake it, dump it. And once you've done that twice, elbow depth. Like I said, you don't have to push this one. You can't contaminate it. Let it fill completely up. Cap it. The big issue with this. This is a microscopic plant. It is an algae. There's 3,000 or 4,000 species in the state of Florida. They replicate on average every 3 to 7 days, depending on one of those species. And they use gas vacuoles, move up and down the water, and get to all the nutrients and light they want. And if you put them in here and take that wind away, because as the wind blows across the lake, you won't see it, but as you blow it, there's microcurrents, and they'll use those to move up and down with those gas vacuoles to go where they want to be. Take that wind away, kind of freak out a little bit, they'll sink. So and they'll keep growing. So what you want to do is keep light off of this. So you want to take it, put it in a cooler, bring a trash bag with you, put a towel over it, however to keep this dark when you've taken it, because in most cases these are small lakes, you're going to be on and off pretty quickly. But some of my larger lakes, they could take these 3 sets, set them down. If it takes them an hour or an hour and a half to sample a lake because the lake's so big, and by the time they get to all 3 stations and get back, they could have actually accelerated growth, because as the sunlight's hitting the water, it's almost like a 2-dimension thing. So it's hitting it. They're replicating at a certain time frame. If you put this on top of the boat and it starts 3-dimension and it could accelerate growth, we're just going to stop that. So just keep it dark. Like I say, kayaks, trash bag or a towel works better. But if you have a big kayak, or like he's got spaces to stick stuff under. So he doesn't even need to bring that. He's got a dark area in his kayak already. So you put that in the dark. That's your algae. So you've got your nitrogen and phosphorus. You got your algae. Now you have that data sheet. And on that data sheet, there's a station 1, a station 2, and a station 3. Station 1, that's where you're at. And this is where you're going to write down your vanishing point, or your Secchi disc reading. About a 2-pound weight, 7.5-inch close disc. The line is a Kevlar coated with a steel insert wire for the center of it, so it won't stretch. Everything that we do in our science stuff is usually metric. However, my boss in '77, when he got here, said science is going to keep metric, but our population is going to keep English. So everything's in 1-foot increments. So everybody can do the same thing. We convert it and we get it, but That's how we want you to do it, because that's what you guys know. The disc, put the sun to your back the best you can. That creates a little bit of a shadow and a shade with the ripples of the water. If you wear polarized glasses, we ask you not to use them unless they're prescription. The reason of that is this gives you an advantage, and I might use, if they don't correct my vision, I could have them on station 1 and then take them off at station 3, and I've changed what I'm doing. So we just tell people, don't wear them unless they're prescription, because if they're prescription, you're going to keep them on. You need them to correct your vision. So no polarized glasses unless they're prescription. Sun to your back. You drop the disc and let it go all the way down until it disappears. Right where it disappears, you slowly pull it back until you can see the whole outline of the dish. And I suggest getting used to this, do it as many times as you want. Disappear, reappear, disappear, reappear. And when you're comfortable, that transition where it disappears, right when you pull it back, you can see the whole outline of the disc. You mark it at the water level. And so when you pull it up, you can say 1, 2, and we only go by quarter, and that's what you see on the data sheet. There's only a place for quarter, half, and 3/4 to circle. That'd be a half. So we would just say 1, 2 1/2. So you put a 2, circle the half, and that would be your vanishing point. That's that transition right there where it disappears and comes right back into view. Some people do this all kinds of ways. Alabama, if you went to school there, a lot of their secchies are taken with a bucket with a piece of plastic in the bottom of it, and they put a bag over their head, and they'll put the bucket down, and they'll take 3 of these and do an average, which is very odd to me anyways, but they do different things. But this is the way most of us do it, and this is how DEP does it, most of everybody else. So that gives us that consistency, that comparison. And there's even a thing called the second dip in that a gentleman, Carlton, Kent State, I believe, started it, and it's been going on every year for like 25, 30 years. My boss helped him get it going too, and they got that all set up. And with that second dip in, we send out an email every year about it, or it gets put in our newsletter. And so a lot of people across the United States go out once a year, take a measurement, and they enter it into the computer. And so they get this huge amount of data across the state for one spot in time. But you guys are going to do it every month, so we're going to get it. And this is the quickest thing for you to see changes. You know, that nitrogen and phosphorus in this bottle and that chlorophyll comes to me. And then yearly you get a report, or you call me and I send you one periodically, or you wait for a meeting and we go to it. This thing right here, you're seeing every day, every month when you go out, and you have that data sheet, and I always suggest to make copies of them before you turn them in so that you keep that folder so you have it. But this is a quick thing for in March, if you did it, it was 5 feet, and then in June you did it, it was 1 foot. You know something has changed. It's a quick indication that you might want to call and discuss some stuff with us. If it stays at 3, and it goes 3, 3, 3, 3, 3, or it goes 3 to 5, hey, actually got a little better. Then it just gives you an idea. It's just a quick way for you visually to see changes without having numbers. And these numbers all come back to this. I know that in theory, if you have a 3-foot secchi or 2-foot secchi, what the phosphorus probably will be in a range. And the chlorophyll is the same way. Whatever this thing is, outside of those color lakes we talked about, that changes the ball game. But inside of a clear hard water or clear soft water lake, this secchi, there's a formula that tells me how much chlorophyll you should have in that water body. Yes, sir.
I take it that this is a test of clarity.
Yes, sir. It's just water clarity. Yes, sir.
And why do we care about clarity?
Well, clarity is as far down as you can see. Most people just clear about it because it's visual. They can walk up and if they like a clear lake or not. But for me, it gives us a whole bunch of data. Like I said, it tells me how much chlorophyll is there. And if I'm sitting in my office and I know nothing about your lake and I have some data in front of me and I look at it and I say, well, you've got a bunch of phosphorus and nitrogen. And you should have 20 micrograms per liter of chlorophyll, and they're in theory right around that. But you don't. You have 2. But now if I go back and find that color data, and that color data tells me that you got 100 platinum cobalt units of color. That's high. It means you're very, very red. I would say, well, hey, that fixes the issue. So if I'm talking to you on the phone, don't worry about it. That's what it should be. If there is no color in it, color is at 20 or 0. And you have all this phosphorus, and what else is going on there? Has someone done something? Has something been put into the lake differently that you don't know about? That leads us down a different road. So this is just one of the oldest units of measure for clarity that's been used. Everybody does it. A lot of programs do it that can't do the nitrogen and phosphorus. So by doing this too, that adds that data to compare to their data because we just have one more piece to the puzzle. And this is that piece. And this again is the piece that you as a volunteer can see immediately. So you can just go out. Some programs are just this. They go out and they take a secchi every month because that volunteer can see this. And if it, like I say, it stays at 2, it's good. You know, it's an average number. But if it goes up and down, you might see seasonality with it. Or if it starts on that incline, that lets you know that something is changing in these parameters because these parameters control this. So As you have more phosphorus and nitrogen, you grow more algae. Technically, you don't see as far down. You have less algae, you see further down. It's just one of the things that's a comparison that allows us to look at those things.
We kind of know what we're gonna see based on the sticky disc, because it's the amount of the biomass of the algae that's in that particular spot. And no two spots on the lake are alike. So, I'll let Dan go in this next part, and then I've got some examples to show you that really support the
Right.
multi-station approach.
As, say your lake is 5 acres and the wind is blowing this way, and the algae, like I say, with the gas vacuoles and wind currents, they move up and down. But if you get a windy day, you might find them all on one side because they just get blown over to that. A good example is in the 80s, I grew up in Okeechobee, and so we grew up on the Kissimmee River and the lake there. And in '86, there was in the Palm Beach Post, a picture was published of the lake about its algae bloom, and that's where it came from. It was a very, it was all taken on one side because all wind had blew all to one side. So it was a great picture of an algae bloom because it was all in one day. But it was been blowing for 3 or 4 days and pushed it all to one side and gave the photographer a very good picture of that. But the same thing happens with you guys. If you have a small lake too, if it's blowing one way, it's like you'll find all the trash on one side. Well, anything that can float, same thing with the algae. If they're moving up and down the water column, they will move over, and you might do your water clarity on this end and be 6, and over here be 5. But visually, that's what it's probably showing you on these small lakes that's moving around. Okay, you're done with station 1. You've done your phosphorus and nitrogen. You've done your algae. You've done your water clarity, and you've written that out on that thing. So you put down your Secchi value on that data sheet. You put down, then there's a sun code spot. It's 1 through 5 for station 1. It's your opinion. Right when you do this measurement with the Secchi disc, the water clarity device, you look up, and it's the full sun, you put a 1. If there's a thin haze, you put that number. If it's a full sun, you put a 5. That's completely your opinion. That just kind of lets us know how cloudy it is right there, how much sunlight you're getting behind you to see. The next thing is water depth. We want water depth. And with you guys, that tells me the Secchi's not on the bottom. So if I get a 3-foot Secchi and I get a 9-foot water depth, it's a true Secchi value. If I get a 9 and a 9, they're on the bottom, and there's a reason. If there's a lot of plants in the lake and that disc disappears in the weeds, not based on the algae, so it hits the plants and you see it disappear in the plants, you measure it, there's your Secchi, and there's a spot on there that tells you put a W right there. So you would put down 6-foot W and then go do your bottom depth, might be 12 or 13. That way it's not a true Secchi value because it's not disappearing based on the algae side, it's disappearing because of those hard order plants. It's disappearing into them faster. So that's there also. You won't have this issue because you guys have been doing it. If your Secchi disc wouldn't hit the bottom, then you would write down 24-foot RS for rope too short. But we've been doing this a long time here, and so you have the Secchis that hit the bottom and all of that. So you'll be able to do your vanishing point, do your sun code, do your bottom depth, and do your time. The time on that sheet is new. That's something the DEP is moving over to a different database. And so in that, we need to have time. And so that's why we add a time to every station for you to write that down. And also on the top of that, there's a thing there that says, I did the phosphorus sample and nitrogen, I did the chlorophyll filter within 48 hours, and I did the water clarity device. You have to check all 3 of those. Even though I know you've done that, that's a new thing that we've added to help out with some different other reasons. Please check those to say that you did them. If you broke your Secchi, then on one of those you would say no because you didn't do it if you had a broken Secchi until we could get one to you. But for the most part, you're going to check every one of those. Some of our rivers that do work for us don't do a Secchi, so they don't check that spot, and that's the reason those 3 are there for you. So check those, and now you're ready to go to number 2. You go to station 2, you follow that same procedure. You rinse your bottle twice, spider grip, elbow depth, fill it up, bring it up, do your chlorophyll, do your Secchi, do your bottom depth, do your time, do your sun code, go to station 3, follow that same process. When you're at station 3, you're going to have all 3 of your bottles, all full, 1 inch out of each one of them for expansion. You put them in the bag. You're going to take your data sheet. If you look on the bottom of that, look on the bottom right there, there's a spot that says, describe what's been going on around the lake. So 2 weeks prior to you going out, you're the scientist. I'm not there, you are. Tell me what's happening. If there's a bunch of birds on the water body, coots, herons, utilizing it, write that down. Give you an idea. For Lake Santa Fe, again, the lake, in October, we started seeing high total nitrogens for about 4 years in a row on the lake. The St. John's Water Management District was looking into a big project, and we're like, what's going on here? Why are we getting this October? We're seeing a change in the nitrogen. I mean, a dramatic 3-fold change. And NOTES found that out, so they didn't have to do the project. It wound up being seagulls. They were landing in October on their way to South Florida landfills, and that was a migration thing. They landed, pooping in the water. went completely up, and their notes answered it, just to give you a short answer there. So anything that you see going on around that, you planted plants, let us know. If you have a contractor and you sprayed plants, let us know. Anything that you think in the area, if you got 9 inches of rain in 3 days, right before you sample, let us know. If you got no rain, let us know. Anything that you think could help us. There's 2 other pieces on the bottom of that. There's a lake staff gauge thing, and there's a rainfall. You probably don't have staff gauges on them, so don't worry about that. It's virtually a ruler on a pole that's surveyed in at sea level. A lot of our public water bodies have them. It gives us, we can count volume and stuff with that, but if you don't have them, you don't write it down. We added that because people ask us to. Same thing with rainfall. We can get rainfall from different areas. If you want to follow rainfall from the last time you sampled to the next time you sampled, you can. I have volunteers that they, in Florida, they always say, you can step across the road, it'll be raining, step on the other side, and it's not raining. So some people want the data for their lake, and they take it, and we keep it. You don't have to do that, though.
And one of the things we might do here, we have put the request out to residents who have weather stations, there's, to do rainfall recording, and depending on where they live, we would know their address.
And attach it to that lake.
There's an online form they can go to and do that. What might make more sense, and I need to discuss this with Sean, is if we get something, a central station here where we make that investment, it could be a nice thing on our website.
Oh,
too,
yeah.
that,
Yep.
Here's been a recording of our rainfall. Then it becomes more meaningful for you and for us to report, and a reliable source.
Yeah, yeah, that would be great, and yeah, then you wouldn't have to put it all on different sheets. You just have one. You could turn it in, and I can get rainfall. The USGS, the water management districts, different people have them out there, and you can get that data. NOAA, different folks like that. But if you have it for your specific spot, if you were trying to answer a question, that might help out. If you know the fall, the rainfall, because we're looking at rainfall. Rainfall dictates water chemistry a lot more than I think most people thought in the beginning. We're starting to see rainfall be a big contributor where most people were looking at different things. We've looked at some different stuff with rainfall and bringing your conductivity up, those ions changing in the water, changes a lot of different things that happen there. So we're hoping to start getting more rainfall data, more water chemistry data to see if that question can be answered. So when you get your data sheet, you fill that out, and then you have all 3 bottles. You just take your data sheet, if you make a copy of it or take a picture of it, however if you want to keep it, you scan it, and then it goes in the packet with these, and you're done. The nitrogen, phosphorus, the every other sample for color and conductivity, your data sheet, it's all right here in one packet. What you're left with are the 3 half-gallon jugs. These 3 jugs, you'll have full. You kept them in the dark until you got back to wherever you're going to do it. It's best the kitchen, garage, or some setup where you can have tap water and be able to do this, because you're going to need a little bit of tap water. You're going to need a level table, and then that's when you're going to you got to get this algae out of the set. And the back side of this little cheat sheet that I told you, the sampling side, if you flip it over, this is the filtering side. This is the side for processing. So what we give you a flask. That's going to hold wastewater. We give you a vacuum pump. This is going to help create a vacuum to pull water through. We give you a filter funnel. Most of them are threaded now. If it has an O-ring in it, the filter's going to go in it. It has a rubber stopper for you to put right here on top. This is a magnetic one. I don't have very many of these anymore because these are very expensive, and this is what we used to buy in the beginning. This is about $380, and so Gelman makes these, and about 10 years ago their patent ran out, and a company called Millipore said, well, we can make a cheaper version, so they made a cheaper version. This one runs about $65 to $70, so as a state agency, I have to buy what's the cheapest, so this is what we buy now. But I get some of these in, so if you have one of these in your packets there in your stuff that Jim has, it's the same way. It's just magnetic. It's nicer, but we don't buy them anymore. Most of them that you'll see will be the threaded kind with an O-ring, and it has a rubber stopper also. It goes right on the top. So there's your vacuum. There's your flask. There's your filter. There's your hand pump. This is your drying agent. This is where you're going to put all 3 of your samples in. Graduated cylinder for measuring water. Oh, thank you. And then 4 steps for handling, pipette for taking water in and out, and then back to labeling. You label the bottles and you label the data sheets. You got to label these too. I got to know where they're coming from. So in this packet, you're going to see 2 filters. The large one is virtually a coffee filter with a label on it to tell me everything is going on. The small one is the filter we're going to put right in this funnel and be able to filter water through. So we'll just pass a couple of these around. You can see them. Has that same information on it. But virtually it's got lake name, it's got county, it's got date, it's got the amount filtered. And that's what you don't know. Jim knows because they've been going out and stuff. When you first do a lake, you don't know how much you filtered, but you have to have a known amount of water to go through here, collect the algae, and that gives me what I need. So, and this can only be worked out in pencil. This is a color test, so any kind of inks can bleed through. So right on the bottom of the filter here it says use pencil only. So you would put down lake name, county, date, the station, which matches the bottles, and then the only thing you don't know is the amount filtered until you start doing the lake. Once you go out and do station 1, the chances are these small lakes, it's going to be pretty consistent through time. Doesn't have to be, but it probably will. And you'll see that, what we're going to do right now. So if you're doing 3 of them, I suggest just taking 3 out, sitting them down, label them, get them all ready. You're going to need 3 paper clips. We only use plastic coated. Again, we only use pencil because we don't want inks to get onto the sample. We don't want these to rust. So we have paper clips and they're plastic coated. So now you're ready to take your sample. Before, you have 3 of them, station 1, station 2, and station 3. Before every station, you rinse this with tap water. And this is where the tap water comes in. So you just take a little tap water. And if you have a sink or whatever you're doing, you just pour a little tap water in it. Let it run through, and then dump it out. And by doing that, you just kind of rinsed out. So it was sitting in your stuff from, for the month before you went out, got any dust on it, you're rinsing that out. And any water droplets from your tap water shouldn't have algae on it. So if they do, you have other issues. So you rinse it with tap water. So you're all set. Now it's all set and ready to go. Rubber stopper. Just kind of snug it, unthread it. And here's where you're going to put your little ones on. These are glass fiber. They have a, I'm going to let y'all handle them, but normally we don't handle them. It has a rough side. It has a smooth side. The rough side is the top of the glass cone, and the smooth side is the bottom of the glass cone. And they're made of all these glass fibers, and these cones are made so water flows through, and algae get caught in those cones.
So smooth is down.
Smooth is down, rough is up. That's correct. Rough side up. The rough side is the top of the cone. So we take our forceps, we grab one, and you can handle them like this, but you just don't want you poking them because that crushes the fibers. So you grab it on the edge, rough side up. That's our rough side. We slide it right on, snug it. Take our top, make her onto our base, and just snug it. There you go. You rinsed it with tap water. You put the filter in, rough side up. Now you go to your sample. You can see this has got stuff in it because Malcolm got it from the edge of the lake and you can't stop that. But if you're out in the open water, you're not going to have this organic matter in it because you're going to get it from elbow depth in the open water, and that's the reason we go out there and do it that way. But this is the color. So what you want to do is you always rinse this with tap water. You always rinse this with your sample. So you put a little bit in. And when you take this and dump it, it's a cylinder, so just turn it. And as you dump it, you turn it, that coats all the sides. So this is tap water because we don't want algae in here. This is your sample so that any water droplets on it are your sample. So then you just take it and you fill it to 500. Now, oh, that's right, we got to shake it. Jim caught me. You got to shake this.
500 or 400?
Well, it depends. I always start out when I'm first training somebody at 500 because this is one complete cylinder at 500 milliliters. And then what you do is you slowly pour it in until it starts to slow down, and then you stop. Then you can come back and you can calculate. Whatever goes in here has to go through because you can't get clogged up right here and pour it back in and say, well, that's what it was. You'd have to start all over at a lower amount. So I just suggest going to 500 your first time, slowly pouring it in, pumping it. If it goes down really good, you put a little bit more, goes down really good, pour a little more until it starts to slow down, then stop, let it go through, calculate what you have. In theory, just from all the stuff I've done, whatever your secchi is usually what you can get through times 100. So if you have a 3-foot secchi, 300 will go through. A 4-foot secchi, 400 will go through. Just on average, it's just a little rule of thumb. Doesn't always happen because like colored lakes, you don't have any algae in it. So even though you might have a 2-foot secchi, you might get 600 or 700 through to get a color because there's no algae growing there because of light limitation. But when we first trained them, we actually went out on a few of the water bodies to put the canoes in. They went out, they took the samples, they brought them back, and then we did it. And so they got that number. Then they started going out on all those lakes, and that number seems to work. And if you can keep a number, if you ever forget and the lab calls you because you forgot to write it down, you always know. But it doesn't have to be. Some of our lakes, the growth period, they'll get 700 through really good in the winter time and have to drop back to 500 in the summer because the algae growth and the different species that really replicate and grow very well in those summer months. However, if you can find a number and it allows you to go through the summer and the winter, it gives you a good color, and you have that number without clogging up, I'd go with it. Oh, that's a good picture.
We did have one clog up, last month, and we.
Yeah, and if you have to, you just drop back.
We did.
Yep.
We don't pour it all in for that reason, because
Right.
it did slow down the vacuum, we weren't getting anywhere, so we had to record a lower value.
And so we're just gonna fill the 500. Like I say, in theory, Malcolm, you got all kinds of stuff in here. I'm gonna dump that, but I've got it all.
Maybe none of that.
There we go. We got rid of the plants, the algae that we had growing there, and some duckweed.
So this came straight out of our.
Yeah, he just grabbed it right there, yeah. So we'll fill it to 500, now we got the plants out of the way. And again, in theory, if you're out in that open water, you're not gonna get that stuff in your sample. So we're gonna run to 500. If you go above, you'll get very good at doing this, but if you go above, you just use your pipette, take it down to 500, or if you need to add a little bit of water, you can. You do the meniscus, that's right. You in our labs, in glassware, we use acids to clean them. They'll etch the sides, and so water will ride up the sides, so you want to read the bottom of that flat spot. In plasticware, if you're not using those soaps and stuff, sometimes it stays pretty flat. But if you do get it right up the side, you want to read the bottom. But this is right at 500. So we have our in our booklet, it really shows you a good picture in there about reading the meniscus and stuff. But that's pretty flat on the plasticware because we do not use acid on these, and we don't rinse it with any soaps. You rinse it with tap water, and so it stays pretty clean. So we have 500. I'm not going to put a whole lot in there because I don't know when it would clog up, and I can't pour it back out. So we're going to go right there. This is your vacuum pump. It helps clear the vacuum. This is technically a brake bleeding pump, and we've had to find a cheap method for you guys to pull a vacuum because our mechanical ones are very expensive. So this is about a $30 item that we can put out there, and it works. So you create the vacuum and start pulling the water through. And you can see, it's not going very fast. So we're going to be I'm not going to put any more in. So we just run that through. You could, we'll just do a little bit more. We'll see how it does slow. That's going through. Yeah, I'd slow down right there. It's got a very good color to it, and I'll show you that. So what I would do is come back, and I would see what we did. We got 100. Oh, right at 2. So 200. We got 200 milliliters through. It's only increments of 5, so that's 200. So you would come here, and you would write down 200. And stations 2 and 3, I would do 200 on those. But since you guys have got something going, you unthread it, and this is what you're looking for. That's a little darker than normal because there's some organics and stuff on that from the shallow side. But that right there is what you see. There's a known amount of algae on this filter based on a known amount of water. And so what I will do is I'll take this filter, I'll take it to my lab, we'll put it in an ethanol bath. The ethanol bath will separate it, we'll put it in a centrifuge, spin it, it'll pull the filter to the bottom, the algae will come to the top, suck the algae off, put it in cuvettes, and we'll shoot 4 light waves through it, and how it absorbs that tells me how much is out there. And so that's why the inks and stuff like that could elevate your numbers and have you a larger number than you should. That's why we only use the plastic-coated paper clips, and we use pencil to write on it. So now we've got to get this off without touching the algae. The magnetic ones, when Gelman made these, they have an opening. The cheaper versions do not. So what you have to do is you have to kind of get underneath it, and you kind of pop it up and pull it and make an algae taco, just like that, without touching the algae. Once it's all done, there's your sample. So the algae's inside, it's folded onto itself, so everything's protected. It's going to be a little wet, so you take a paper towel and you blot it. That takes some of that extra moisture off, sticks it together so it can't come apart. Then you have your label, which you written only in pencil, and you put your 200 milliliters there. You fold that. Then you take your algae taco. Oops, sorry. And you slide that right in here, and that's one complete unit. There's your algae taco. You take your plastic-coated paper clip so it won't rust. Put it right on the top. Drying it. This is just a silica gel. You put that right in there, and that starts the drying process. And you'll put number 2 in and number 3. And since you guys do a few lakes, you can put them all. You can put most of them in this. You can fill this up with them for the drying process. Most of our lakes, they only go out and do one set of samples. They come back, they put it in here, and what they do is they cap it. Once they get all 3 of them, they put it right in here, zip it up, and that's one complete unit. And they put it in the freezer. This silica gel, you see, there's a blue and a white. The blue is the indicator. It's very expensive. About a gallon costs about $200, and the white's about $25. So we quarter blue, 75% white. And so once the blue turns white, we know it's all full, and we just stick it in a microwave and pull the moisture out and put it back in. So that's kind of how it works. But that's your drying agent. Some water body groups don't use it. They take the samples, put them in the freezer, and send them to their labs, and then they have to dry them. This helps us dry it. With the amount of samples that we're getting, we need it ready to go when it gets there. So this have it dry when it gets to us, and it keeps any kind of growth and stuff like that from it. But you would just go to number 2. Same thing. You would put this back together, rinse it with tap water, put it back on, put your filter on rough side up, snug it, take your jug, shake it, rinse your cylinder, fill to 200 since that's what we got through, run 200 through, then you would put number 2 in here, repeat it, put number 3. Only using 200, you could completely do all 3 of these in this one container. This is only a 1,000 milliliter flask. If you are doing 500 or 400, you can only do 2. And remember to dump this, because what will happen is if you forget to dump it, water will come through the tube and it'll get all over you, and it'll wear these pumps out faster and get you wet. So what you want to do is remember that when it gets about to the neck, go ahead and dump it. Or some of the volunteers say, I never remember that, so they just dump it every time. Just every time they do it, they just dump it, and that's the practice that they do. It keeps it going. So when you're done with number 3, everything's in here, all 3 of your samples. You would open up your bag of bottles that you already have sampled. Your data sheet is in there. You made your copy of your data sheet. You fold it, one complete unit, goes right in the freezer, and you're set. If you're doing multiple lakes, you'll have multiple bags of bottles, but you only need one of these with all your samples in it. But for the most part, one volunteer does one lake, and they have one set like this. Goes in the freezer. Periodically, you turn it into your collection center. Closest one to you guys is Lover's Key. There's supplies there that whenever Jim and them would do it, or sometimes I had to come by this area, so sometimes Jim would just meet me at like the CVS over here on the Pond Road, and when I left Lover's Key, I would just pick them up on my way to Rotunda from him. He would give them to me. You get new supplies, and you just keep doing the sampling. When you're all done, everything gets tap water rinsed. Just tap water rinse everything, air dry it. It goes right back in the tubs that we provide you guys, and you just store it. And most of this stuff you can't hurt it. So the bottles, the filters, the desiccants, we always have them at Lover's Key, or we give them to Jim when we come by and we pick everything up. The hard items like the filter funnels and the flasks and stuff, if something like that goes out, the pumps do wear out, he just emails me, or you guys can email me, and I'll give you information, and then we mail you a new one. Yes, sir.
We could use an extra flask.
That's what Jim's talking about. Yeah, I'm going to leave you this one. I brought it.
And like I do Ashbury Circle, 3 stations. Each one we measure 400 milliliters. Now, if one, let's say I can only measure 150. Do I do the next 2 at 150?
No,
Still
try it, yeah.
Still
But now next month, if it does if you go to the next one and it's like, man, it takes me 10 minutes to get that 400 through, then no, drop it back. This should only take you, like you saw, 2 or 3 minutes to run a filter through. Don't want you sitting there 10, 15, 20 minutes, because theoretically, you could get that 400 through, but there's a time issue. We don't want you sitting there for 30 minutes doing it. This should be a 2 or 3 minute deal. So 400 was working, and you got a bloom because, you know, we got a hot summer day. You got a different algae species took over for that month or a couple months, and that first one went down, took you a lot. The second one started to slow it down. Just stop. As long as I have a color and I have a number, we can run your analysis.
You know, we do bring out a waterproof camera, and I think it's important that anything we observe, like, you know, we noted a large bird population on that lake, and so we may see that in the data. We also note the wind, you know, direction and speed. But we did see an accumulation of planktonic algae on the shore, and it was, you know, you could even see the wind lines in it. And as we went to our different sample points, we could easily predict what we were going to see in the data, and the Siki readings were lower at the higher concentration of algae, and then much different at the upwind point of the island, which is station number 3. And so I just like to take pictures of these sometimes because it creates a nice visual. This information I include in my reports to the board, and it's posted on our website. So if you look at the Lakes and Ponds page, at the committee page, this information's out there. So, and we had even seen it on another lake out in the middle, very middle, and, with the wind, it looked perfectly clear on one side, but coming in much differently at the middle. And so, again, we just make those quick photos, and then as we did the data, sure enough, right at that mid station, we saw a much higher algae concentration. So we think we like the fact that we're doing multiple stations on each lake, because if we just did a grab from the shoreline, which I know is the Pond Watch approach, and we want to talk more, we want to share this with Ernesto and talk with him, maybe it gives us some consistency in the nutrients, but maybe not so much the biological productivity that's taking place in the lake. And when I went out, I thought it was going to be a beautiful day on that lake, and then I got out in the middle and I saw the swirls of algae. I knew what I was going to see.
Water, because as you saw, that wind pushed that algae to one side, so 1 hour had more than the other. And if we were only taking samples at that one end, we'd only have that one value. But by taking 3 stretched across, we get that average, so that gives us a good picture of the open water, what it is. Anybody have any questions? Again, everything gets stored in those tubs. I'm not sure where Jim keeps it, if you guys keep it at your houses, whatever you do, but it can go there. I think he has 2 or 3 of those sets. That way you can hand them out and you guys can go out and do. And it'll be up to you guys to decide how you do it. Like I said, most of my volunteers, they live on that lake, they have their boat on it, they go out on it, they do it, they come back, they're always there. You guys as a community will be changing and sharing and doing that side of it. But
And how often do you pick up a Lover's Key?
every 3 months. So like I just came through here in December and got everything, I'll be back in March. And that's on our website, you can see that, but I also emailed Jim 2 weeks prior to us coming through the area, and I always let him know that, hey, if you've got samples and can get them over to Lover's Key, I'll pick them up, or do I need to come by and grab them? However that works out, we always take care of it and get them. Yeah. And then like in Collier County, Naples Conservancy is our collection center. So all of our volunteers they take them up to the Conservancy. Kathy meets them there, and they put them in the freezer, and she gives them new supplies, or one of the biology technicians there help them out, and that's where they go. Again, there's very few lakes in those 2 counties, but like you go to Orange County, I have 4 collection centers in that county because we have 70 lakes being turned in there, and they're all over the county. So it's a little
How many lakes in Lee County do you know?
And Lee County? I don't know. Do you have any idea? Yeah, that one I don't know. I don't have an answer for that.
I just have a question in regards to like how many sites you tried to gauge for like one community. So say a community has 12 lakes, are you letting them pick which lakes they want to sample based on whatever their issues are, or do you
I go
sample your
either-
outfall, or?
I go all of the above.
Okay.
It just becomes kind of a decision we could discuss when you find, like with them, I told them that we couldn't put all the lakes in this group in. So what we tried to talk about was either ones that they were concerned about or the hydrology. If it flows this way through the community, maybe you do one in the beginning, one in the middle, and one at the end, and that's like Rotunda. I couldn't do all of the Rotunda stuff in Charlotte years ago, so what we did is they have a couple big natural lakes that we did, but on all the little ponds that run through the community, we picked one on the north, one on the south, and let them do that. So it was like 2 or 3 out of their 12 to do. But that's something that like we would discuss, like if it was like a community that you were working with, and there was they didn't really have a concern other than just getting some data, maybe we pick 2 lakes. If there's a concern that over on this outfall there's a problem, then maybe we pick those, and then maybe a control on one end, so that once they don't think there's a problem, that way they pick 2 lakes or 3 lakes, and it'll just be called with me and you, we can just discuss it and see what, and you will have an input into that on what do you think that they need in that community, what would help answer their question, or maybe it's not a question, maybe it's just an ability to collect data, just to have something because it's very easy 10 years from now and to go to one of the managers and say, well, this has happened. And they go, well, okay, show me something. That's one thing that, like my boss said, this is a good insurance policy for you as homeowners with your water bodies. You now have a data set that 5 years, 10 years, 15 years down the road, if changes occur and you want to do management, this will help you with that. It just won't be you saying, well, this lake never had algae in it, now it does. And it's one thing about that, because people get caught up in that where, well, it was this way years ago and it's not now. That's why some of the data reports, when we start talking about them, you'll look at some of those stuff as we went back and done cores 1,000 years ago to see what algae were growing in those lakes at that time, because that helps us give an idea that, well, maybe this lake wasn't as clear as people's minds may have been. 15 years ago, because we're seeing the same amount of algae present 500 years ago or 1,000 years ago in that lake that we see today. So it might have just been expressed differently.
Just based on that. We did pick a control lake, and we cover the full spectrum of trophic states.
Yeah,
as a result. So, you know, and we're seeing some changes, but we're seeing some consistency and some maintenance. So,
And that's where, like I said, the University of Florida, the extension side, that's where we come in. You get that data, I run it through my lab, and then if you have a question, and I have those circulars or ones that he has in his library, we created those to help you guys, in a layman's term, be able to read through it and understand it. So if you want to know more about the phosphorus, you can go pick that up and read it and understand it. There's one on there about plant communities and fish. There's one on there on bacteria. There's one there on fish kills. So there's to answer certain questions that help you all out, and we tried to make it with the data, but turn that data into a way that is a lot easier to understand. And so that's why it's there. And we're talking about those reports. Once we have 5 years, like those reports come in based on how DEP looks at your lakes, about impairment with that nitrogen, phosphorus, to color, conductivity, and the chlorophyll. We also, once you have 5 years of data, we put graphs with them and we put statistics with them. So if there are trends, either positive or negative, we statistically test that for you guys and we give that to you. That's another reason those reports we only do them once a year. They take a lot to do it. We have a new professor that just started with us, and he's real big in a program called R. And so he's going to try to write us one that allows us to move our data from our statistic packages into Excel and use Microsoft with the report. With R, it's supposed to talk to both of them, and he's going to do it. And hopefully about another year, I might be able to make those reports whenever you call. And that would be a good thing. But he hasn't done it yet, so I don't tell people we have them yet. We have to see if he can actually do it.
Question. What about where, like Somerville, like we've already got the aerators? Is that where you test from, how does the aerators affect the testing?
well, we have 6 designated lakes, and none of those lakes have aeration, but 2 of them are being considered for aeration soon. And so this is where it kind of gets exciting with the data. Now
You
we
have pre-data, you have
establish some baseline data. We would expect to see a trend improve, not just in the lowering of nutrients, we will consider.
No, but I mean the actual testing, like Somerville where we already have that. Would you test the 3 spots where the 3 aerators are, or would you try
keep
and
them the
get
same.
away from
Yeah,
them?
yeah, you already have
That's a
sites
great
on that, you
point.
can't change the sites, you stay with the sites that they are.
Because if you
So
look at our
how-
station maps and you look at the proposals from the system that's coming in, they're right on the money.
Right.
So we can't change.
But
Yeah.
what about Somerville's, which is already there? Is that where our testings are?
We do
Right
not
now.
test on that lake.
You don't test that lake? Okay, so.
It's in good shape, I can tell you, just by looking at it.
And
Yeah, but
that's
we
where
don't
those
have
notes
the
come in.
fish we used to have.
Well, you'd be surprised, and this is where we've promoted the angler diaries.
Uh-huh.
We've also promoted the aquatic bird survey. I just happened to go out the other night and in my lake, and which it has its issues, but again, this is just kind of a show and tell thing. But it requires some discipline to count, to maintain. Like I counted the number of casts over a period of time, and recorded the success I had with that. So, like you were saying, they're just right up on the weeds. So I think once you kind of know the routine. So, does anyone fish in your lake?
Oh yeah, the people, I'm not going on that, I'm going on what I can see.
Okay.
Right.
I
Well-
live on the 2nd floor, and every year I have seen these fish mate, and how they do their little round.
That's from an exotic.
It's not
and they
happening
might
this
have-
year.
And you might have gotten a cold snap, and they might have died.
Yeah, it's been like a year and a
But
half,
they're-
I haven't
but
seen
They're
it.
temperature sensitive because they don't belong here anyways. They were brought in. The FWC brought tilapia in years ago, and the idea was it was going to be a plant eater like a grass carp, but you guys might have some of those in your lakes. We use them as a management tool to remove vegetation. They are more of a omnivore. They eat detritus, so they're a detritivore, but they get worms and stuff accidentally, so they kind of fall into that omnivore a little bit, but they virtually just eat around the bottom. They thought they would not grow past maybe Orlando, but now they're all the way to the Panhandle. They've been here for over 20 years. They're starting to acclimate, but they're a cichlid. You can go get them. Different types of those in your aquarium store and stuff when they come in. But temperature is still sensitive to a point. So when we have a hard freeze. We might go 6 or 7 years, and the populations jump up. They make those big beds, and then if we have a freeze, they might die back. If you don't get all of them though, they'll slowly rebound and come right back. But just kind of answer your question, it's like when you start looking at fish, and they like for South Florida. Well, had a guy in Broward County. He had a contracting firm that sprayed his lake all the time. He said, okay, there was a fish kill. He blamed it on them. It wasn't due to that. It was due to a turnover. We got a bunch of rain. That cold water hit the water and it went down to the bottom, and it caused it to flip. So it brought a lot of low oxygenated water up through the top, and it went uniform and caused an O2 issue and killed them. Well, they thought that it was maybe a herbicide. And then all these fish, he said, there was 1,000 fish on his lake, and it was a 30, 40 acre lake. Went there, put one of my electric fishing boats in to show him, and after about 20 minutes of us doing a gear that they can't get away from, you don't have to be a good fisherman with this gear. He was, okay, let's go back to shore. There was plenty of fish there. For a fish kill, you have to walk across it. There
hasn't been a fish kill,
Yeah.
like just hasn't been
Yeah.
there.
And just visually seeing.
I could
Yeah.
see them out in the middle swimming, you know, big ones, you don't see the big ones.
And grass carp that's what I would think you would be seeing in the middle. If you are stocking grass carp in the lake, you don't, because those guys will come up in the middle and they'll swim across it during the day, and they live 12 to 15 years depending on different things. When they die out, that's what people say, oh, I don't see the big fish anymore, and half the time it winds up being those, and they're a management fish. They're an exotic that we put in anyways, and they just die out. But they do. Fish move, populations change. We see populations go up and down with different things, and especially after a cold event, especially with you guys down here with the brown hopolos, the armor catfish, with the tilapia, with the different the plecos, the big algae eaters. You see those in these lakes, and you see them die out after cold events. And sometimes, you guys probably remember, was it 6 or 7 years ago when we had the bad one? We even had snook, coastal fish dying. And we were working on a reservoir in Tampa, and the amount of fish that just floated up there was incredible. But it was a lot of exotics that just can't handle that cold snap.
We, especially armored catfish right now.
Yeah.
We're seeing and documenting, big armored catfish.
Yeah.
It could be like expectancy, they're at the end.
Yeah.
But a little bit of cold added to it.
Yeah,
So
and-
we're only seeing a single species, and we kind of let the vultures tell us.
Yeah. Okay.
To go see. So when I drive through the
Okay.
street and I actually see the vultures.
Yeah.
We're circling. I
And
go
you know,
over and take
yeah.
a look, and I take photos of those too. So
Okay.
we're hopefully not going to develop a form. We had talked about it when we do have fish kills. I think it's important we note that it's a single species, because
Right.
that can be explained a lot easier. If it's multi-species, then
Yeah, and if you start having that where you see a bunch of them, there is on our fish kill pamphlet, there is FWC number there to call. There's also some numbers there to a couple of our vets at UF. It gets difficult to run down reasons why unless we just can look at the weather and we can see and come up with an idea that this is probably what happened. Because in many cases, if you have one dying, we need that fish alive back to the vets to be able to culture to get it. If we already have a dead fish, it gets much more difficult because all the other bacteria and erosion and stuff that's starting to happen to that flesh gets in the way. And so if you were to see this on a basis that you say, well, this is happening all the time, you would have to try to get that fish as it's starting to die, keep it alive enough to get it to an FWC office or U.S. vet office where they could actually look at it and culture what might be happening. And we do have certain things out there. We have bass virus, we have different things. And we have fish species that they are like a boom and bust species. They just go up, stay 7 or 8 years, and then they bust. And then they start back up 3 years later. Why some of these species do that, we don't know. We just don't know if it's virus, if it's bacteria, if it's just the way that they cycle. Same thing with aquatic plants. Aquatic plants do the same thing. We'll see southern night in one lake for 6 years strong, and then something happens and it'll disappear for a little while. But the seed banks are always there, and they usually come back.
I think we're close to 20 trained volunteers now within our community, so that's pretty exciting. I organize a schedule every month, try to get it out at least a week in advance. It's really up to you guys to choose your task of choice. That could be something as simple. Steve Putnam was kind enough to donate these, and I was lucky enough to fix one of them because when it didn't work, I about had a heart attack, and then he said to donate it. But this has been great because it allows two people go out. They carry the kayak to the water and the supplies, and one person stays on shore with the clipboard. And both of us have the two-way radios, so we're able to communicate those readings. It really helps speed up the process, and it doesn't require you to get on the water to get involved in this. I just like to go on the water myself, so.
Are you limiting the testing to, or the sampling just to the 6 lakes that are in trouble, or are you trying to cover all the lakes?
Well, it would be great if we could do all the lakes, but again, our ability to do that, and it's a big commitment, you know, we would have to commit to doing that monthly, and then it really comes down to Dan, is
Yeah,
his
right
lab's
now, the
ability.
6 have to be what we do just because of what I'm able to do with my lab, yeah.
But we're looking at the Lee County Pond Watch, having the individual come in next week to do a limited site survey, to also provide training on Pond Watch. But it would be good if you guys come to that, because it's very different. It's similar results that we were given, but the collection is what differs. They do a shoreline graph. So my question is for Ernesto will be, when we look at these samples where we see such a broad change in the chlorophyll from one end of the lake to the other, you know, and we're married to a spot, you know, how much are we gonna really get from this? But that's something we could bring in as a complement to what we're currently doing and include other lakes and possibly do it on a rotation, you know, so we have some data on all of our lakes.
Are you pretty confident, Jim, that the 6 lakes that are being tested are the 6 most vulnerable ones?
Actually, yes, because of the fish kills that we've had. 2 of our largest fish kills that have occurred here are in 2 of our program lakes. And I don't think it was just coincidence. I think Dan gave a lot of input into the selection. Yes, Steve?
I think we've talked about, we don't know yet for sure until we meet with Ernesto, but we were thinking we might be able to expand, because that appears to be a far less involved process, maybe expand the Lee County Pond Watch program to all of our lakes to at least begin to catch some baseline data. I don't know yet
We
whether
haven't
that'll
jumped
work or
into
not.
that because we really want to get our needs covered here and make sure we're committed to this. I mean, this is not something we're just gonna do once, we're gonna do it every month and try to go at least a 5-year period with that. So you guys are, you know, I don't know if you've signed up, Dan's gonna have some forms for you to complete. I have everyone's email, because you did email, so you'll receive something from the Sandoval Lakes Gmail account, which will have a schedule that we'll lay out. I think it's gonna be next Thursday. I have to kind of look at my schedule. We try to batch these in a single day, and sometimes things go wrong. Like, I got out on the middle of the lake last time, and there was a bag of mulch floating in the middle of the lake. Well, I had to tie it off. I mean, it was like dragging back a whale, you know, to the shore. But so we'll set this up. You guys will have the opportunities to participate. It could be recording, you know, being on shore, getting on the water. If you got a boat and you live on one of these lakes, that is best case scenario, because it eliminates the transport of the kayak around the community to the different lakes. So, and if you just want to come and process the data, we do it at my garage. You know, we have a setup there. We batch through everything.
Can you make a couple copies for me?
Yes,
Yeah, that's
yes,
over.
Carol can do that.
And it's a lot of fun.
And all of our, all of the information in terms of the library for Lake Watch, the trained volunteers, the lakes that are included in the program, maps, our inventory is even tracked in that sheet. And so there, you know, so that's something that's maintained and available to not only us, but to Dan.
And that really helps, you know, keeping the inventory sheet for you guys, you know, that way you know what I have to leave, we don't have to leave too excess stuff, you know, you have what you need, because we'll be by every 3 months.
Okay, and Pamela, whatever you need from us, you know, we've built some of these things, you're welcome to them.
Yeah, just looking through your spreadsheet, it's actually very impressive, so
Okay.
I commend you guys.
The sampling looks pretty easy, minimal training to get that done. The testing, on the other hand, would require a lot more training than we've seen today. And you did a good job, but that's a lot to process. You talked about batch testing at your garage. Could you elaborate on that?
So what I'll do is I'll send out a schedule for the different lakes that we're gonna go to, an expected time to be there. Individuals can choose, if they'd like to get out on the kayak, I'll be happy to accompany them, actually provide any direct support there as they go through all the motions on the water. We then bring it in. If they want to continue to go to other lakes, that's fine. I could be meeting someone else at the other lake. we're working on bringing you guys in, not just shipping you out on your own, but I would be that resource to join you on the water, or to have you over, as we have everything collected at the end of the day to process through the filters. We have 2 complete lab kits, so we're able to run things in a batch mode at that point as well.
Just that top part of Sandoval rates and then just name and contact.
Don?
Do I understand that are you actually trying to add more lakes to your sampling now, or
Through other
just looking for
programs.
more volunteers?
Through other programs, yeah, we'd love to set up our own lab, but then we don't get the academic support or the external third-party analysis, so, we had considered that, but it doesn't make sense.
So you're trying to add more lakes?
Just the top.
Not to the Lake Watch, not unless they say okay.
Yes.
I guess that's a question for Dan.
Yes, sorry.
So Don was asking, is it possible for us to add new lakes? And what Dan- I can answer this for Dan, because what Dan's gonna look for, how good are we doing with the current lakes? Because if we're sending him good data and we're keeping up with it, then maybe that's a better time to ask Dan.
I would say, yeah, once you get going, this is about the number, but what we'd have to do is, I can't add any more legs, but once you got 4 or 5 years on one of them, or you got 3 or 4 years and we were comfortable with that, we could maybe move to every other month sampling and then add a lake. That way I'm not adding any more samples, but once you have a good data set started, and maybe we don't do monthly, we do every other month, we could add another lake and then do that. But right now, the 6 or so lakes that are in the program is about as far as I can go for just this community.
So we could alternate.
Right,
but
you could,
let's-
yeah, you could alternate, and if you wanted to say, well, we want to add 3 lakes in a couple of years or so, then maybe we take the other 3 lakes and we just do them January, March, and we do the other one on February, April, and add
I
that in.
guess as an alternative, what we could consider doing if we wanted to would be use that, we call it Seiki,
Uh-huh.
disc. Just use
Now, you
Seiki.
could always do that, you have it.
Yeah, use Seiki data on the other lakes and maintain our own database.
You surely
and then
can.
We could monitor it ourselves.
Or like Ernesto's gonna be with him, it's sampling a little different, but some of the lakes that you might wanna move into, start that there and see what you start getting compared to the other ones, and that way you have 2 different programs doing the different things, cause does he do, I know he does he do phosphorus and nitrogen on his?
Yes.
Does he? Okay.
Yes, it's a single shoreline grab, so,
Yeah.
and it has to be collected on the
You have to bring
second
it to-
Monday of the month
Yeah.
and delivered, because they'll process it that evening.
Yeah, they do it in their lab that day.
When I told him all this stuff that we do here, he thought, whoa. So he may have questions for us as he comes in. I just have one thing to pass out, because each time we do this, we learn something. So what I've done is, and with the group, is we made a record of this. So this is kind of our lessons learned so far. It breaks it, so the purpose of this is really to document refinements recognized during each sampling cycle towards improving efficiency and minimizing errors, because we had some broken bottles. I mean, everything went wrong the first day that Steve and I got back out in the canoe. Luckily, we didn't tip, but we kind of learned.
Nobody drowned.
Well, that's the most important thing. We do wear our PFDs when we're out there. I mean, again, I'm on the water all the time. I'm never out there without it. It is part of what keeps us safe. But these are things, I've got enough copies for everybody, and we welcome any feedback. But just so you know, we're always kind of, we want input from you too on things being better. Don, I think that was a great idea. If we can get things under control with our current lakes and then start weave in other lakes within there, we have to determine what those problem lakes are, and it could be through sticky disc measurements.